Hello everybody, and we have Master Advanced Physics for all top exams, and today our topic is relative velocity. Relative velocity. So when you have two bodies moving with respect to each other, then how would the second body look to the first, and how would the first body look to the second, and that would be relative velocity. Actually, in real life, if a body is coming towards you and you are also moving, then it is not the real velocity, it's actual velocity that you experience the relative velocity. The velocity actually changes. So we have three situations of such relative velocity. Situation 1, one-dimensional motion, which means straight line, no angles. One-dimensional motion of two bodies moving opposite to each other. Opposite to each other. When two bodies are moving with velocities v1 and v2 exactly opposite to each other, then the man at the body v1 or v2 will experience a velocity, that is relative velocity, that is v1 plus v2. Plus v2. It will get added up. This is obviously a very common experience. We must have all had this experience when we travel in trains. When a train comes opposite to us and crosses us, it seems to be going faster, isn't it? It seems to be going faster than its actual speed. We know that is not its actual speed. It seems to be going faster when we look at it. Why? This is because we are not stationary. While the other train is crossing us, we too are moving ahead. So obviously, plainly, the velocities get added up by the reality of the situation. Isn't it beautiful? So that's how it is in physics. Situation 2, one-dimensional motion of two bodies moving in the same direction to each other. Same direction. Two bodies are going towards in the same direction, but in a straight line motion, one dimensional only. When two bodies are moving with velocities v1 and v2 in the same direction to each other, then a man at the body v1 or v2 will experience a velocity, will experience a relative velocity, we can say, relative velocity, that is v1 minus v2. v1 minus v2. This is a common experience when we travel in trains. When a train is going beside us, in the same direction as us, it seems to be going slower than its actual speed. Why? This is because we are not stationary. While the other train is moving beside us, we too are moving ahead. So plainly, the velocities get subtracted by the reality of the situation. Now we have situation 3. Now, even two-dimensional motion of two bodies is possible, isn't it? You are going at a certain direction, and another body is not going opposite or in the same direction as you, exactly opposite. It is going at an angle to you. Then what? Like for example, there is a river flowing and you are crossing. So the river is flowing in one direction and you are crossing. It's almost like two perpendicular directions. They are at an angle. It can be even two things being at an angle. Then what do we do? It's very simple. We have already done the chapter on vectors. If those who have not done, please go back to it. You will understand it very easily. Here we simply take the relative velocity of the two bodies as the vector difference of their velocities with respect to some origin. That's all. It has to be vector difference, isn't it? Because there are two vectors. Here velocity is a vector acting at an angle has to be either added vectorially or subtracted vectorially. Here it is relative velocity, so we have to subtract vectorially. So VBA is a relative velocity is equal to VBO, velocity of the first body, minus VAO. And we have put it in the dark. It means they are vector subtraction. We have to do vector subtraction. Not addition but subtraction. There are many such examples, boat and river examples, umbrella examples, which come usually in problems, and we will see them when we do problems based on relative velocity. Once you understand the problem, there we will explain to you how we are carrying out this concept of vector subtraction. Okay, that completes relative velocity 1. Thank you.